All right, welcome back. I'm Bill Westlake, and this is Lag Demon Programming. Where we left off, we actually got this semi-running, where our game comes up. It displays a little banner first. It puts out a command prompt, and we can type show, and it shows us the current room we're in and tells us what the exits are. Now we're going to make that a little prettier and easier to read, but I just want to get the information on the screen right now. Where we left off, what we had done was transformed this so that these rooms are pointers. And in our create room, we're doing new. All right. That means we're creating an object on the heap. And right now, this is a memory leak because we're not disposing of it. The way we're going to dispose of it is we're going to create a destructor. And the way we do that is by putting a little tilde and then DungeonCrawl game, this. All right. Now, there's always some confusion about this virtual destructor. Very simple. We could give you the rule to say always make your destructors virtual. That's not necessarily a good rule. It's better to understand why you use a virtual destructor. You want to ensure the correct destruction order. And when you're using classes with virtual functions, which we are, this virtual keyword in front of the destructor will ensure that destructors get called in the correct order. Since in object-oriented programming, it's very rare that you have a class that isn't using virtual functions, it's a very common thing to see virtual destructors. If you have a very simple class that's just a data container that doesn't have any virtual methods and isn't derived from and doesn't do a lot of other things, you don't need to use it. As a general rule, however, you will put virtual in front of the destructor. So what do we want to do? Well, let me explain this. We are creating the rooms here. There's no other way to create a room within this than call this create room. This is private. Nobody can access any of this stuff from the outside world. The only way to get a room into the system is to call this method, and this is where it's doing a new. So all the rooms in this will have been created here, so we want to be the ones to destroy all the rooms. And the way we're going to do that is with a for auto room colon rooms. So we're going to loop through them, and we're going to call delete room. Now this is a guarantee. Every single room that we create here is in this list because we put them in this list right here. And so we're going to go through every single room and delete it when we destroy this class. So when our program exits here, when this game loop finally exits and we leave, that destructor will be called on game because game will fall out of scope. That's another important thing. This DungeonCrawl game is it's a local object to this main function. And when main leaves its scope, the system will automatically call this destructor right here on game. And game will loop through this vector and delete all of those rooms so they'll all be cleaned up. But we don't have a way to exit. We're killing the program right now, which is fine. In reality, the operating system is going to clean up all that stuff when the task ends in most cases. In this debug mode here, we don't exactly have a way to exit at the moment, but we're going to fix that right now. We're going to go back to our DungeonCrawl, our game CPP here, and we're going to make a first command up at the top here and say if command equals exit. We'll call this function we're going to create called game over. So here we're going to come down here, make sure I'm in the right one. I am. We're going to create a function void game over and we're going to call running equals false, and we're going to change our loop. We're going to come up here and private bool underscore running equals true. And here in our game loop, oh, put that in the wrong place. This is why we're calling game over. I put this in the wrong place. We're going to go to game.h, create this game over function. We can make this private bool underscore running equals true. I don't know why that's showing up. Here in game.cpp, here's our game loop. Instead of this, we're going to say while running. All right, so that's a little cleaner now. This is a terminatable loop, and it'll terminate when we call game over, which will set running equals false, and our command does that. Let's see if that works. If it compiles, it doesn't compile. What's wrong here? Oh, semicolon. Got to watch those semicolons. They're easy to leave out. So if we type exit, there, we exited. And when we did so, that destructor was called. So let's do something here to show that. Here's our destructor. I'm going to go standard cout from room pointer get name from is being deleted. So let's see what happens. We run it, we type exit, and there's our two rooms. Start room is being deleted, store is being deleted. So there's your proof that when we fall out of scope, you notice we didn't have to do anything here, such as delete this or do anything to it. When this fell out of scope, when this main exited, the system called that destructor right there, and it ran, and it told us that those were being deleted. So we don't need that there anymore. We know that they're being deleted, and it did, in fact, delete both of the ones that we created. So that cleans that up. All right. Now, tokenizing. Tokenizing, what we want to do is the same kind of thing we did in the other games. So I'm going to pause the video here and go pull up that other previous code that we worked on so that we can look at how we were doing some tokenizing and see if we can improve it a little bit. All right, so what we want to do is tokenize our command that we type. And so we've got our eval command, but we really don't want to do this. Okay, this, for one thing, it only allows us to type one word. We got to type it very exactly. What we want to do is tokenize this. So there's a couple of things that we need to do. If you'll remember, we created some functions for trimming up a string. So I'm going to go ahead here and create a special module just for this kind of general string manipulation stuff that we're doing. And so I'm going to start by adding, and this is going to be a class, so I'm going to add a header file. And I'm going to call it string handlers. And I'm going to create a CPP file by the same name, add new item. Just a regular C++ file, and we're going to call it string handlers. All right. So what we want to do first of all is I'm going to go ahead and grab that trim stuff that we had and put it in here. We already kind of went over this. I'll go over it again a little bit, but paste this in here to the CPP file. And we need our white space constant thing here for that to work. All right. And then in the header file, we're going to put these declarations. So let's go to that header file, string handlers. We'll leave the pragma ones, that's fine. We're just going to get rid of the implementation part here. This on the end, and we need string. All right. So we've got the ability to trim our input. We just want to get rid of trailing and leading and trailing white space. So rather than, because this stuff really has nothing to do with our game, so it's best to, and plus these functions, they're just pure functions. They don't manipulate or use any outside state. They don't cause any side effects. They don't do anything to the system, and they're very generic. So we're just going to make them as standard functions in this standard file. That's perfectly acceptable. Now, we want to have a more general tokenizer system. So what we want to do is be able to break down I'm going to add in IO stream and several other include files, and I'll explain what these are here. All right. So this is this S stream is a string stream. Then it relies on stuff related to IO streams, so we need that. Algorithms has a bunch of interesting algorithms in it. We're going to use one of them. And iterator allows us to create some very special iterators. So what we want to be able to do is take a string and break it down to a vector of words that have no white space around them. They're just individual words, because our commands are going to be things like go start room, okay, or exit, or pick up item, or pick up name, or whatever, a variety of different commands. So we need to break those down. So what do we need to do? We need to first get a vector. Did I include vector? I missed that one. So let's include vector. All right. So standard vector string, and this is just going to be a list of strings, standard string. This is going to be a vector of strings, and we're going to call it, well, they're not really tokens, they're just strings, but we can treat them almost as tokens, but we'll tokenize them later. So right now we're just going to call this split standard string. It's going to split this string into a bunch of individual words based on white space. And the way it's going to do that is, first of all, we will go ahead and create our vector. We'll just call it words. It's got to be standard vector string words, and that's the result that we're going to return. Standard string, I'll get it right one of these days. Now we're going to use something in algorithms called copy. But actually first, before we can use copy, we have to create a couple of things. We need this iString stream. This is an input string stream called ISS, and we will pass it our command. This will be a complete command string. Command. So what's that going to do? Well, it's going to create an input stream like cin based on that string we passed it. So this is an input stream that only contains that string we just got from cin, but now it's in a special container that we can manipulate. We've passed it as a string into here, and it's inside this input string stream right now. All right. So now what we can do is go standard copy. Well, copy has a bunch of crazy stuff we need to pass it. We need to pass it an standard iStream iterator of strings based on ISS. Oops. And again, we do the standard string ISS. All right. We also need to pass it an iStream stream standard iStream iterator string. This one will be empty, standard string. And then we're going to use the standard back inserter on words. Okay, I know this is crazy, and this is working with the standard template library. It can be very interesting. These are various kinds of templates, and we're going to eventually get into templates and what they do. But basically what this is saying is create a way to iterate on this string as though you were an input stream iterating. Input streams collect individual words broken by white space automatically. That's why we used getLine and didn't use the cin directly, because we wanted to get the whole line. This will pluck out each word and iterate on it, pass it into this copy based on this iterator and this back inserter. So what does this do? Copy will force this back inserter to push each one of those words into our words vector. And so what we can do here is return words. Let's see how this works. All right. First of all, I'm going to grab this and put it in my header file. So we've got a reference to it. Oh, we got to add vector here. Vector. All right. Okay. So over here in our DungeonCrawl CPP, we've got this. I'm going to get rid of this for now. We don't need any of this junk. We're going to include that header file. String headers.h. And let's go vector standard vector standard string words, we'll call it, equals split command. So that's that split function that we created here. Split. We pass it in the command. Sorry. So let's iterate over that real quick. For auto word colon words standard cout and let's run this, and we'll just type in some individual words and see what we got. This is a test of our split function. There it is. This is a test of out split function. All right, let's make sure that there are no white space attached to those in any way. So we'll put a quote, 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 and a quote, quote, quote. We'll put little quotes right around it. And if there's no white space in there, there shouldn't be any white space. So let's see what we can do. This is, we'll put a tab, a space, 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 test of word parsing, space, 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 tab, test. There they are. All the individual words, no white space, nothing. Okay. We don't even actually have to worry about trimming this. We could, this is a test, and all that. But we have our trim function in case we need it for other things. I wanted to move those over because they're useful, but that breaks those individual words. Now what we can do is actually think about tokenizing them into something that makes sense in our game. And I think we're just about out of time on this video. So what we've accomplished here is quite a lot. We've got now the ability to break down the individual words for our commands. We learned about destructors a little bit, and we learned about deleting our memory that we've allocated using the new command. So we're making progress here. We're coming along on classes. Basically, a class is a type. It's a complex type that contains inner workings. A class contains both data and code, and the code can act upon that data within there and keep everything nice and consistent and consolidated. And we learned a little bit about the lifetime of pointers. We're creating the pointers here, and we're deleting the pointers here. We're guaranteeing that the lifetime of these pointers we create is no greater than the lifetime of our class, of an instance of our class. All right, thanks for watching. I hope you enjoyed the video, and if you liked it, hit that like button. If you really liked it, hit the subscribe button, and if you want to get notifications when I upload videos, hit that notify button. Thanks, and I'll see you in the next video.